Hello everyone, myself Sourav Nayek. Today I am going to share my interview experience at JNCASR through JNCASR entrance test. So there was 7 professors in my panel, and one of the professors asked me to write down the Heisenberg uncertainty relations, and there are 3 relations. The relations are between position and momentum, and one is the between angular momentum and the angle, and one is energy and time. And I wrote down 3 questions, and after that they asked me that where we experience the Heisenberg uncertainty principle in real life, where you see that effect. And I told them that we can experience it in double slit experiment, in single slit experiment, as we all know that whenever we are using a electron gun, whenever we are using an electron gun, we know the electron momentum, because most of the electrons are getting through that one slit, so we know the momentum, and also the position, because the photographic plate behind that, all the electrons are going through that narrow slit, so that we also can get the position. So there will be simultaneously measurement in position and momentum, but it's impossible to measure the uncertainty in position and the momentum simultaneously, as Heisenberg says. So for that we get many peaks, ups and downs in diffraction pattern to just protect the law. And after that they asked me to write down the 1D harmonic oscillator, the potential of harmonic oscillator, 1D harmonic oscillator, and I write down that potential. And after that they asked me about the energy eigenvalue we get from that potential. So I also wrote down the energy eigenvalue, and they also asked me for 3D, and as we all know, I have write down the equation also here. And after that they again asked me about the 3D harmonic oscillator, and I also wrote down that thing also. So and after that there was a question that is conceptual, that for every time will there be the omega same for x, y, z 3 axes, and the answer is no, because we all know that for intrinsic harmonic oscillator, the omega basically will be same for every direction, every x, y, z axis, but not for not intrinsic, that will isotropic. For anisotropic there will be no same thing. So after that they asked me to write down the degeneracy of ground state and the fast excited state for 3D harmonic oscillator. And as you all know, for 3D harmonic oscillator, the energy, the degeneracy in energy will be 1 for ground state, and for fast excited state there will be 3, as you can see respectively. And that was the question. After that there was a question. I had to solve that question fully, but here I am not going to solve it fully, but I will just give the preference of that answer. So the question was, if we introduce a charged particle under the influence of electric field, there will be different result if the electric field is not given, but the question was there basically electric field was given. So what will be changed in that, if a charged particle is introduced inside a quantum harmonic oscillator under the influence of external electric field basically. So as we all know, the electric potential become minus QEX, as you all know, and that's why I modified the potential equation. And after that, through the the algebraic equation solving, basically not solving, the rearranging the algebraic equation, I get a term that is like here you can see. So after that they asked me to draw the wave function. They were asking me, will there be any change in wave function due to change in the potential? And I said yes, there will be a change, there will be a shift. And they told me to draw the wave function, and I draw it there. And as you can see, the wave function that have become that one. So there is a x minus x naught term. So for that term there will be a shift either on the positive direction or either negative direction. It totally depends on the value of x naught. And after that they asked me, will there any change in energy, will there any modification in energy? We in many ways we can check that will there be any kind of modification in energy or not through many steps like perturbation, but here they did not ask me to do it through perturbation, rather through the algebraic equation, arranging of algebraic equation. That's why I did it, and there will be energy correction and is there will be the energy correction. That term will be in every I mean the energy level, and it's not like that it will directly contribute due to the value. It's actually a constant value, and that will shift every energy, but the difference between energy levels as usual it becomes h car omega, and for all time that difference will be every time h car omega, but because that part will be added to every energy levels. And after that there was a last question and there was a graph. They asked me to plot the y equal to 1 by x square minus 4 graph, and I tried it. So as first we all know that we can write down at x equal to 0 y will become minus 1 by 4. So here I will plot the graph. And at x equal to infinity y tends to 0, as you all know, and at x equal to plus minus 2 y tends to infinity. From these respective values we can draw the graph easily, and here if we just plot the we can easily plot the graph here. So at plus minus 2 we can see here there will be negative infinity value for this graph. So we will draw on each point. So at first at x equal to 0 y will be negative 1 by 4. So let us pick the point as a dash point, let minus 1 by 4. So as you can see at x equal to plus minus 2 the graph will tends to infinity. So the graph will be basically like that way. And also there is the points like x tends to infinity, the graph y will be tends to 0. So at on the above point of plus minus 2 the graph will be like that, because it's a even graph 1 by x square minus 2, so the both peak will be on the upper side. So that's the graph that I plotted, and to professor helped me on this graph to plotting the graph. And that was my interview, and thank you, and thanks to Physics Galaxy for giving me the chance to share my interview experience on this platform. Thanks.